What's up, guys? We're going to continue with Chapter 9. This lesson's on solving quadratic equations by graphing. You'll see it's a pretty easy lesson because we did graphing all of last chapter. This whole chapter of Chapter 9 is all about different techniques that you can use to solve a quadratic function. So here we go. We're going to skip through the exploration. Core concept here. All right, when you are solving by graphing, you want to get that quadratic function equal to 0. Okay, once you've gotten equal to 0, we're going to graph the related function as if it was y equals. What we're looking for is the x-intercepts. Those x-intercepts could also be called the solutions or the roots or the zeros of the function. Those x-intercepts are our solutions. So when we have a problem like this, x squared plus 2x equals 3, we're going to start by setting that function equal to 0. So we're going to subtract the 3 from both sides. And then we're going to get x squared plus 2x minus 3 is equal to 0. From this point, we're going to factor. Because if I get it in factored form, I can see those x-intercepts. So it has to multiply to negative 3 and add to 2. Remember, factoring has to multiply to c and add to b. So if I think about things that are going to multiply to negative 3 and add to 2, how about a positive 3 and a negative 1? So I'm going to get x plus 3 times x minus 1 is equal to 0. Using our zero product property, we can solve for our x-intercepts here. So we're going to set this equal to 0. Subtract the 3, x is equal to negative 3. There's one solution. Add the 1. And x is equal to 1 is my other solution. Those are my x-intercepts, so if I plot those, they would be here and here. If I wanted to see the full graph, I could find my axis of symmetry and my vertex by doing x equals p plus q over 2. So x is equal to negative 3 plus 1 over 2. X is equal to negative 1. So I know that my axis of symmetry is at negative 1, which is halfway between my intercepts, which makes sense. If I wanted to find the vertex, I could plug that in to any one of my equations. So y equals negative 1 squared plus 2 times negative 1 minus 3. So my y value of my vertex, if I do that math out, 1 minus 2 minus 3, my y value is negative 4. So I know I have a vertex at negative 1 comma negative 4, which would be right there. Go ahead and graph that. And there's your graph. Okay, so now, did I actually even need to show the graph? No. If I just find those x-intercepts here and here, I know that that's my solution. Those are my solutions to the quadratic function. So again, the x-intercepts are the solutions. Why? Because that's when my quadratic, my y value is equal to 0. Okay, so that's the key thing here. The x-intercepts are the solutions. I don't think we need to go through these. We'll do this one. I'm not even going to graph it. I'll show you how to graph these on Desmos. Add the 16, add the 16. So I've got x squared minus 8x plus 16 is equal to 0. This is actually a perfect square trinomial. And this is going to factor to x minus 4 times x minus 4 equals 0, or x minus 4 squared. So there's actually only one solution here. If I set x minus 4 equal to 0, I add the 4 to both sides. X is equal to 4 is my only solution, which means that your vertex is actually going to be your x-intercept here. Let's keep going. Negative x squared equals 2x plus 4, the easiest thing to do here. Let's add that x squared over. X squared plus 2x plus 4 equals 0. Now, this one is a little bit trickier because you actually can't factor this. So, because there's nothing that's going to multiply to 4 and add up to 2. The only things that could work here would be 4 times 1 and 2 times 2. So nothing works here. So this would be a really good example where you'd want to use Desmos. So we're going to star this one for now. And then we're going to go back to this when I show you on Desmos, x squared plus 2x plus 4, and I'll show you how to find those x-intercepts there. Now, if you're given a graph and you're asked to find the x or find the zeros of this, all you're looking for is where it crosses the x-axis, those x-intercepts. Because remember, the x-intercepts are the solutions to the equation. So if we look here, we're going to have 3 x-intercepts here. We're going to have an x-intercept at -1, an x-intercept at +2, and an x-intercept at +3. So your x-intercepts are equal to -1, +2, and +3. As points, these would be -1, 0, 2, 0, and 3, 0. And you could also get those other x-intercepts if you factored this, because if we factored this, this would be factored to x -2 times x plus 1. And if we then solve for 0 on those, we would get those same 3 points. Again, now they're just asking you to approximate the zeros to the nearest tenth. So now we don't have exact values here, but we want to approximate what each of those values are. So again, this is just a guess. But if we took it to the nearest tenth, I would say your x values are -3.8 right here, because it's a little bit shy of 4. And then maybe, let me write that a little clearer. And then x equals probably about -0.2. And again, as points, these would be -3.8, 0, and -0.2, 0. Oops, wrong way. When you're given a problem such as this one right here, where you're given a word problem, your best bet is to use Desmos and graphing this word problem, okay? When you use Desmos and you're asked to graph that or answer questions related to that, keep in mind that the x-intercepts would represent where you're starting with the ball and then where the ball ends, okay? If you had to find the height of the football after each second, you could just plug in the time into that equation and you can get there. And again, if you want to see use the result of part A to estimate what the height of the football is 50 feet, you would just look for a y value of 50 feet to get that answer there. So I want to show you how to go about using Desmos on both of these to help you to answer questions such as these.